Okay, all right, so just reiterate, since I didn't hit record, in case anybody misses this and is, watching it afterwards. We finished all the material before our first exam. We're going to do the worksheets today, and then we'll have another review on next Monday, on the study guide sheet that's on the resources tab under La Lima. So things being slow here. There. I would highly recommend, whenever I teach M161, I highly recommend printing out this colored, even in an in-person, especially in an in-person class, print this out, and you basically can take notes all over this during the lecture and make little notes about, group 1 is +1, group 2 +2, group 3 or 13, whichever numbering system you like, +3, right? 4 carbon we left alone, and that's why there's a whole year of organic chemistry. It's so versatile. And then group 5 has a -3 charge, group 6 -2, group 7 -1. And then, you can put hydrogen at times above here, above fluorine. And later in the semester, we'll get to things where helium could be over here above beryllium. And I would just sort of, take a pencil and like sort of dot it in those two places. And then, this thing is color coordinated, and like, so a color printout, Kinko's, FedEx, wherever, UPS store, all these kinds of places. If you don't have one at home or access directly to one, it's like 50 cents. It's definitely, considering all the time and energy you put into the class, it's definitely worth it. Okay, the worksheets. Get it to share. All right, just moving things. These worksheets were designed for a 4th hour class, where an undergrad or potentially whatever, a graduate student ran them, where it was in person, and they're kind of meant to be as like an in-person practice test type thing. So I would, we'll go over and do it here. Some of these I would sit down. They'd be good to sit down the blank ones, no answers, and see if you could do it without digging through your notes or looking back in the slides, or pulling up the answer key. And then if you can't, obviously do that. But I would take that periodic table that I had up before, and probably, not right after class when we just covered it, but wait a day or two, and then see if you can do these. Kind of the same thing with the study guide. They're designed for, they're kind of meant for an in-person class, which means in-person tests. Whereas, on an online test, there's got to be more made-up things that aren't real. There's got to be a bit more math problems, even if the math is super simple. And that's, done in an attempt to make things where you can't Google them, right? So the point of the class is to learn the stuff, not to give an exam where see who can look things up the quickest. But if you know the answer to things and you don't need to look things up, then you answer that problem quicker and get on to the next problem, the ones that you have to solve. Okay, I feel like I'm rambling. So these first 2 chapters are kind of basic science review, and usually the problems that I pull out of it are ones that are important for the future stuff we're going to do. So this first one, right, 1 is a molecule. What's a molecule? That's 2 or more atoms chemically joined, right? It's definitely not mixtures, pure substances. We talked about mixtures. And so if it's not a mixture, it doesn't matter if it's pure substances or, 2 or more elements is describing the molecule. So A, B, D and E describe mixtures. That's clearly not it. I don't think there'll be one as easy as two on the test. Define a gas, right? This is just going back to that slide that's in a table form for solid, liquid, and gas, right? So a solid has a defined volume, defined shape. Liquid has defined volume, but indefinite shape. And then a gas has no defined shape, no defined volume. 3, a substance composed of 2 or more elements in fixed definite proportions. These terms, they'll get used. It's the answer is compound of the ones given here, right? So a multiple choice test, you're picking the best answer that's there. This sounds a lot like what was above in the sense of a molecule. So if compound and molecule were here, both in here, you could argue for one or the other. But also molecule could be interchangeably put in here in between. A compound's sort of a better umbrella term that would describe an ionic compound and a molecular compound. But if compound wasn't here, molecule would also be a decent answer. An alloy is a blending of 2 metals. And they're not that, an alloy doesn't have to be in fixed ratios, right? And we saw this on the slide that talked about brass, how it's a mixture of, I forget, copper, and I think it's zinc. And, there was all different ratios from 5 to 95%, I think, in each direction. 4, there won't be something like this on here, right? This is just chapter 1 stuff, kinetic energy. Energy associated with motion of an object. This is more Newtonian physics, right? It's talking about force and gravity, etc. And you'll really see in the next chapter we get to after the exam that we want you to start to think about these things called energy diagrams, where it's the chemical bonds that determine the potential energy of molecules. So molecules with high energy bonds have potential energy the same way, when you're riding a bike down a hill, you have the potential energy when you're at the top, right? Because gravity's pulling you down. So things tend to be in lower energy locations. And so in the Newtonian physics sort of way, if you're on a bike at the top of a hill, gravity's pulling you down, you go downhill. It's the same type of thing. And with chemicals, where, for example, gasoline has high energy bonds in it, it's at the top of the hill, right? And that's why you buy it and put it in your gas tank, is you can harness that energy and get it to do the work you want it to do. And the molecules that come out tailpipe of the car, CO2 and water, are low in energy. And things in lower energy don't react, they don't do much, right? So when there's a hill and you're on a bike, you can put into motion and do things at the top. When you're at the bottom, you're out of energy, right? You're at the bottom of it. Sig figs, I think I put one sig fig problem on the test, and it's a really easy one. This one is you're multiplying 2 things together. When you multiply, it's how many digits are there. Whenever there's a decimal point, the zeros afterwards, you're measuring those. And then when you add things together, it goes by the location. So tenths, hundredths, thousandths, right? And since you're adding this one, it's the thousandth place. So this one would have 4. I think the one on the test is easier than this. It's just thrown in there because it's covered in the book, and I kind of ran out of problems to come up with. 6, water is an example of, this is pretty similar to the ones above, right? These problems in the first, chapter are pretty easy. You have to know the formula for water, which I assume people do, but if you somehow forgot on our test, you can just Google it, right, and see that it's H2O, so it's clearly not a single element. Water is often a mixture with other things, right? But that's not what this is saying here. So of the answers, A is the best. And this is another one where, right, a molecule would be a fine, a correct answer as well. This one tells us we have a mass of mercury that occupies this volume. What volume would an equal mass of ethanol occupy? So this is just a density problem, but sort of given in a roundabout way. It gives you the density here for mercury, and it gives us the volume. So from those, you can get the mass of the mercury, which is then equal to the mass of the ethanol. And then you use the density of the ethanol to find what it was asking for, which would be the volume of the ethanol. And this makes sense, right? Mercury is a metal. It's one of these weird liquid metals. So it's about a liter, right? The density of mercury is about 13.5. So that means it would be about 13.5 grams. And then this density of ethanol is lower. So you'd be dividing a number like around 13 or 14 divided by a number below 1. And so it should make a bigger number. So you would expect an answer, like this, somewhere between 14 and 17 or something like that. So 16.3 seems reasonable. 8, identify absolute zero. So absolute zero is on the Kelvin scale. And then the difference between Kelvin and Celsius is 273 by definition. 0 degrees Celsius would be 273 Kelvin. So this is sort of the opposite answer. And then the other one, 212 Fahrenheit, is just made up. I definitely put a temperature in interchanging between the temperatures on the test because that uses math. And there's a density one on the exam as well. Because those are easy to make up and apply. You can just Google or flip through the book and find the answer. This next one, we've got some boat that spills diesel oil into the ocean, 3 barrels, right? Each barrel contains 42 gallons. The oil film on the ocean is 2.5 times 10 to the second. So that's, there's 250 nanometers. How many square meters will the oil slip be? This is a little, this is just a unit conversion one. I didn't put one like this on the exam. So, and I didn't put a nanometer problem on the exam. We'll see that in a later chapter. But, this is just a unit conversion one. So from the 3 barrels, you go to gallons because there's 42 in each, so times 3. So that gives you your volume. Then you need to get out of gallons. And since this is in nanometers, you need to figure out the gallons in a similar unit. So square meters is probably best, right? I mean, you could use nanometers, but that's a really small number. This didn't specify the units. So this is another thing where these worksheets were meant to be done, in small groups in person and working them out. And even if you were given the answer where you worked them out in class to find the right math and the right way to get there. This didn't specify the units, but the exam will. So I think I put a few fill in the blank ones. And I definitely am not trying to trick anybody with sig figs on the fill in the blank, the numerical answer one. So for example, right, 3.0 specifies 2 sig figs, right? 42, there's 2 sig figs. 2.5, there's 2 sig figs. So your answer should be in 2 sig figs. And if someone gets one wrong or something on the test because you put in an extra sig fig, I can go through and give you the point back. So I'm not real strict on that. The point is that you can, especially like this one, you're doing all these conversions to get to the right answer. I don't want people to lose points because you know, put in 1.92 or something. Scientific notation, it's just on this worksheet because, you know, this chapter 1 covers sort of basic science stuff. You'll see as we go along, chemistry tends to be, if anything, we change units like milligrams to grams, but the numbers and the things that you're doing are more, tend to be more tangible. So your answers are usually between, 0 and 1,000 or something. In Chem 162, you'll have some bigger and larger, huge numbers for different constants to individual chemical reactions. But it's rare that we're using numbers like this. And this is usually because you weigh things out in a lab. It's all setting you up for lab work that you would do where you weigh out, 2 grams or half a gram of something. And so the numbers aren't extreme like they might be in engineering. So there's not a scientific notation one on the test. All right, let me go to the next one. These are also set up. You got to understand that like these are made per week during a semester, and the 4th hour when you're in a class, the classes I was normally doing were like 100, 200, even up to 3 or 350 sometimes. So the 4th hour would happen anytime Monday through Friday for 20 people in a classroom or 30 or something like that. So it's not really set up like worksheet 1 is chapter 1, worksheet 2 is chapter 2, or something like that. They overlap a little bit. So you'll see, like here, a sig fig problem on the second worksheet where there was one on the last one. And that's because some people are taking their 4th hour on Monday and other people are taking it on Friday. So there's a little overlap between the two. Okay, like I said, there's only one sig fig one on the test, and I think it's easier than this, but the decimal point tells you that however this number came about, somehow these zeros were measured, so they're significant. 2 is a density one. Mass of an object is what you're looking for, has the volume and the density. So this is just unit conversion, right? You can see, right, the number should be 2.2. The 88.6 would be on the bottom. So we're looking for a number. When you rearrange these, you're just multiplying them by each other. Right? So 2.2 times 2.22 times 88.6. So 197 seems about right. This is pretty similar to what would be on the test, right? You're given 3 sig figs in both of the numbers here. So, and those are the only 2 numbers you have to use. Your answer should have 3 sig figs. And usually I'll have it where the unit is there and it's just a blank spot for the numerical answer. Okay, 3, this is a good example of what wouldn't be on an online test. Because right here it's saying which law, right? We've only covered, I guess we covered a few laws, but a few of these answers are made up. We haven't covered the first law of thermodynamics, but on an online test where you have access to the book, you could just look up these things. But you save yourself time when you already know something versus going and looking things up. Anyway, definite proportions is the ratio of the masses of the individual elements in a compound. So they saw that repeating pattern, and that's how we get chemical formulas, H2O, for example. The law of conservation of mass is builds us to our chemical reactions, right? You react A and B, they have to turn into products where that mass is still accounted for, it doesn't disappear. There's no law of the modern atomic theory. It's not a law. Multiple portions is we covered that with the definite proportions. And then thermodynamics we haven't gotten to yet. The subatomic particles, we covered electron, neutron, and proton. We haven't talked about an alpha particle yet. The nucleus is the neutron and the proton, so it obviously can't be the answer if it's the combination of two of the things. And then this is where we went and talked about the masses of things. So an electron has such a small mass, we ignore it. 5, this is a good type of problem, especially since it's generic in the sense that it has just an X here, it's made up. Determine the number of protons, neutrons, and electrons. So the formatting for this is a little off. It's a long story why, but I'm opening this in this neat program. The other one was Word wasn't working for some reason. This is an older desktop, but it works. The internet works better than my laptop. Anyway, so 12 should be down here on the bottom. It shifted this thing, the numbers up. So 12 tells you the element that it is. And the C here, it looks to me like this was a multiple choice, and then this didn't get deleted or something. 25 is the mass number, and that is the protons plus the neutrons. So 25 minus 12 is 13. And then the charge goes after it, and there's no symbol there, which means it's neutral, so the protons and electrons equal each other. 6 is, this would be one that's on maybe on a Chem 161 in-person exam where you're given a periodic table, but this is the easiest of this. Like, if you can't do this, then you should drop the class, right? This is just asking you to find the symbol for it. And if your periodic table, if it's any good, and I always use that one that I gave you guys, but it's just not in color when it's in an in-person class. But the name and the symbol are there in the same elemental box. So that's basically a free one if you've paid any attention. Ions. So this is similar to the one above, 5. An element has a number of protons. Ions means that it has charge. The protons never leave the nucleus. So the way that something has a difference in charge is that it either gains or loses electrons, because ions is an umbrella term for both positive and negative. Number 8 is the beginning of naming compounds and applying, 7, the charges above. So this is just finding aluminum on the periodic table, and it's group 3. Let's go back to, right, so aluminum's right below boron. So whether you like the 1, 2, 3 or 1, 2 all the way over to 13, again, if on my periodic table I'd use for the exam, I would make a little note and write a +1 above group 1, +2, then +3, like leave carbon neutral, then -3, -2, -1. Those plus and minus charges are pretty hard and firm. With stuff we'll get into more in Chem 162, but the second, this row, really the third period, but of the main elements here, aluminum on over to chlorine. These ones can have some expanded and unusual oxidation states from 3 down, but these elements are metals and get used less. So really just silicon over to chlorine down to iodine, these non-metals. And it's not many metal or many elements. Where were we? 9. Identify how atomic mass of an element is determined. It's an average of the atomic masses. sorry, of the isotopic, but it's that weighted average, and there'll be one of those on the test. That must be on the next worksheet, I would think, because it's got to be on there. There'll be one of those on the test, right? So has nothing to do with ions. I don't know what crude weights is supposed to mean. The number of protons is the same for any elements. That makes no sense. We haven't talked about radioactivity, so none of that really makes any sense besides B. How many iron atoms are contained in 3.5 or 354 grams of iron? I don't think I put one of these on the test. I don't think I put an Avogadro's number on the test. We only use it in the chapter 2, just reiterating that you know that the atoms are really small things, and so in order to get masses, tangible things that we as humans can use, basically in a lab, you group Avogadro's number, though that many of them together to get the mass to match the atomic number that you see on the periodic table. So for this, you would go to the periodic table, get the iron, the mass of iron, and that would tell you how many moles this is, and then just multiply it by Avogadro's number. Pretty sure I didn't even put one of these on the test. And 10 and 11 are just the opposite, right? So here you're in atoms, so then your conversion factor is Avogadro's number. That gets you out of atoms into moles. Then the mass of zinc off the periodic table. So these ones are decent little unit conversion ones, but I didn't actually put one of those on the test. How many electrons are in each neutral atom of magnesium is sort of a strange and roundabout way asking this without giving the symbol. In any of these ones where it's how many neutrons, electrons, protons, there's no fractions, right? Either you have an electron, proton, or neutron, or you don't. So answers D and E don't make any sense. You need to go find magnesium. It's right here, so it's 12. If it's neutral, it has 12 protons. It must have 12 electrons. How would CrCl3 be classified? I mean, I guess you could call it a pure substance, as you know, it's written here. It's just saying that. But an ionic compound is sort of the better answer. It's definitely not covalent. That's when you have nonmetals. Here we've got a metal and a nonmetal, and it's certainly not one element. There's no proton there, so it's not an acid. So ionic compound, I would say, is the best answer, but it does say circle all that apply. So pure substance. But you know, this problem, this is a bit too easy for our test. So you kind of get a feeling for what the difference between these in-person exams versus an online one would be. It's got to be, you know, even if the math is simple like the one above, there's got to be some math where it's not just looking something up. Where's worksheet 4? Where's worksheet 3? 3. Make it a little bigger. All right, the first one here's what looks like an atomic mass one, saying silver has an atomic mass of 107.868. The silver 109 isotope is 48.16. What is the AMU of the other isotope? So this one's really close to a normal average, which is 50%. But it's actually not exactly 50%, right? So 107.8 when the 109 isotope actually weighs this amount. If it was the normal average, you would take the 109 and the 107 one, add them together and divide by 2, right? Because that's 50%. But in this one, you multiply 0.4816 times this value. And then 48.16 minus 100 gives you the percent of the other one. And you know what the total equals to. So it's really a solve for the unknown. And if we look at the answers, oh, these answers are really close together. This is a bit silly. So this is, I didn't create this one. I would have deleted these or changed them. These values in here are really close together, right? 106.905, 908, 903, 911. I would put values of like 105.8 and 107.9 or something. These are almost rounding and really close. I usually put an E, none of the above, and I usually have one E, none of the above on the test. And then I put usually one, sometimes two ridiculous answers that there's no way the answer could be that. These ones are really close together. Calculate the atomic mass. This is the same, math type of problem. Generically, it's calling it element X. Two isotopes masses are 45 and 47. Specifically, right, we round these up in general when you talk about them, but specifically 45 means 44.8776, and 47 means 46.9443. It's not a normal average, right? Otherwise 45 plus 47 divided by 2 would just be 46, which seems like it would be answer B, but it's not. Right, since it's 67% of the heavier isotope, we'd expect a number closer to the 47, which means above 46. So B doesn't make any sense. D is really close to the heavier weighted isotope as it is, so that one doesn't make any sense. You can already see A's bubbled in here. It's closer, and then C could make sense. So this is more typical of the type of multiple choice that I put in, where A and C are in the right range. B and D, they're not ridiculous, but they're obviously incorrect. There's no E, none of the above here. But you need to get out your calculator, and so you multiply each number times its percent, and then add the two together. So 44.87 times 0.3288, and when you add those together, you get 46.26. 3 is talking about carbon 13, and it wants to know how many neutrons. So you look up carbon on the periodic table. It's the 6th element. The mass comes from the protons plus the neutrons. So 13 is equal to 6 plus your unknown. 6 plus 7 is 13. The answer is C. This is a little bit, this is the type of fairly straightforward question. It might not be an element that easy to find or something, but right, this still has math in it. If you somehow, if I just generically labeled it X and put the protons in here, then it's something you can't Google. So, and that's what problems on these online tests are usually intended to be like. How many neutrons are in magnesium 54? So basically the same question as above, right? Just a different element. Not magnesium, manganese. You need to go look up manganese on the periodic table. find its number and thus its number of protons. And I don't know that one off the top of my head, so we'll do it together. There it is, Mn, 25. So 54 equals 25 plus what? 29. D and E are ridiculous answers. You can't have fractions of electrons. So B is the closest reasonable answer, then A is the number of protons, but D and E make no sense. Which element has the chemical symbol Rn? There's not, there might be one like this on the test, but this is kind of too easy, right? All you're doing, you could Google that, copy and paste it, or just pick up the periodic table and find it. That's a bit too easy. The formatting on this one looks a little strange because one kind of looks like capital I. So it almost looks like 1,311, but really it's 131 I for iodine. And this is an actual isotope that's relevant and has importance with nuclear energy and things like that. Another one gives you the isotope, contains blank, fill in the blank. So find the number of neutrons. Protons plus neutrons equals the mass. So this is another one, and I don't have the number memorized for iodine. It's over here, it's 53. So 131 equals 53 plus X, solve for X. 131 is the number protons and neutrons, so that's wrong. 53 is the number of just the protons. I don't know what 184, where that comes from. And so it looks like B and D are just numbers taken at random. Or maybe 53 added to 131 is where 184 came from. Anyway. 7, how many electrons are in nickel 2? So again, periodic table, nickel's the 28th element. So if it's neutral, it has the same number of protons and electrons. So neutral would be 28, but it's plus 2. Electrons are negatively charged. So subtract 2 from it, and it means there's 26 electrons. 30 is clearly, 28's neutral. 30 is clearly, if you went the other way, forget that they're negative or something, right? The incorrect math. Some of these ones where the math is really simple like this, the inverse or opposite math is done and that answer is there. 8, all the following are nonmetals except, this is kind of similar to number 5. There might be one problem like that, but certainly not multiple ones like you see here in the first couple of worksheets where you're just going to the periodic table and finding the answer. That's a bit too easy. But A is a metal. The rest are all nonmetals. So there's an extra period there. I don't know why there's periods on any of these. Nine's a bit too easy too, right? The charge is written after the element. Cation is positive charge. So that would be none of these. C, D, E are all neutral. There's no charge indicated. And then A is an anion. So that one's a little too easy as well. 10, again, another kind of looking it up. But these ones like this, the better you know it, then the less, if you're reading problems in the future, you don't have to go look up definitions. And an ionic bond is where you have cations and anions together. So the difference between that and a covalent one is that it's a metal and a non-metal, and the electrons have left one and gone to the other, and so there's a charge associated with it. Then covalents are non-metals, and it's the opposite. Right? The elements actually share the electrons. And we'll revisit ionic and especially the covalent bonding, and we'll do all the math and especially show where what the electrons are doing in these covalent compounds in future chapters. 12, this, right, is if you have the color-coded one, periodic table, most elements are blank at room temperature, so solid, liquid, gas. The things in red are liquids, which there's only really 2 of, and then it's subtle, but right, dark blue are all these nitrogen on over to the noble gases, and chlorine, they're all gases. The element symbol name is written in dark blue instead of black. But if you have a black and white copy, that's hard to tell. But again, that one's a little too easy. So keep in mind, these were usually meant to be in-person little worksheets for people to do without the periodic table if possible, and then when needed, grab the periodic table to find and look it up. Identify the diatomic element below and given its chemical formula. Kind of strange, only gives you A through C. I wouldn't say that that'll be directly on the test, but hydrogen and then nitrogen, oxygen, and all of group 7. And this is why hydrogen a lot of times is put here above fluorine. So nitrogen, oxygen, and then that whole group 7, which in this sense includes hydrogen. Those all come as diatomic molecules, X2, whatever the element is, which is important when you're doing other problems. Because if you think it's just the individual element, then you would grab the molecular weight for just the element instead of the diatomic, or double. So your answer will be off by a factor of 2, higher or lower, depending on what you're doing. So I don't know, I wouldn't say that problem 13 is, directly on the test, but it's probably incorporated into a problem somewhere on the test that you need to know what those select few elements that show up as a diatomic. And the reason for that is they get used so much, right? We breathe oxygen and nitrogen and hydrogen gases and fuel cells, and then those halogens get used for a lot of things. People taking OChem, you'll use bromine and iodine as Br2 and I2 in the labs. Let me just look if 5. Yeah, 5 still covers stuff we did. So we can do 4 and 5. Let's go with 4 first. Since we're doing the test on Lima, like writing out the formulas, that's what this one says, but that's, it'll be multiple choice, or it'll be fill in the blank for a numerical answer. Copper 2 sulfate pentahydrate. So penta means 5, so 5 waters that if you put it in an oven, it drives them off. So answer C at least has the 5 waters, right? It doesn't mean 5 times the chemical formula, so just glancing at it, C and E could be right. A doesn't make any sense. That's hydrogen, that doesn't make sense. B doesn't have the 5. So then what's the difference between C and E? C just has sulfur in there. It doesn't have the polyatomic ion sulfate there. That looks a little better. So E is the right answer there. I don't know that there's one quite like this, whether it asks you to pick the right name to the element. But again, this looks like something you could just copy and paste into Google and find the right answer. And I try to minimize those. Identify the false statement about acid rain, kind of another thing you could like Google during one of these tests, these online ones. So, but this emphasizes why we study things like this and want you to walk away from learning something from freshman chemistry instead of, memorizing some formulas or something. And we'll come back to acid rain, but it comes from those polyatomic ions and the combustion of things that have nitrogen, which there's nitrogen in the air, so all combustion has it. So nitric acid as acid rain, it is naturally occurring. And sulfur is too when you're around a volcano, but a lot of coal has sulfur in it. And so you get a lot of sulfuric acid near power plants that run on sulfur. Not many power plants in the United States run on sulfur or run on coal. So there's not as back east around Pennsylvania, those mountains there's more coal back there. So whether you've seen it or not would be somewhat minimal, but other countries still use coal. I mean, you kind of got to use what you have access to. And then we didn't get to this, but a lot of old artwork, kind of more European stuff, but marbles and statues and columns and stuff in cities that are near these power plants, it actually slowly over time, and depending on what you do in lab, you can see acid dissolves a lot of things, and that's why our bodies generate HCl in the linings of our stomach. The sulfur is in the coal, so that's where the sulfuric acid from acid rain comes from coal power plants. So those two are kind of related. Then acid corrodes a lot of things besides marble. It can react with metals. And again, you'll see some of this in 161 lab, depending on what labs are covered and the details in which, I haven't seen the lab manual specific to ones that some of you might be taking. The molar mass, this is just going to the periodic table and getting these. This is a classic thing in an in-person test, but in one of these online ones, you can just Google, copy and paste this into Google, and it's on Wikipedia and etc. So a bit too easy. There'll definitely be problems where you use it, and those are coming up on these worksheets. Here's a molecule one. This is another Avogadro's, which I don't think I put on the test. But the critical part is, right, grams to moles. And here you can see how, like, we want to make sure that you know where the molar mass comes from, right? The mass of the individual elements added up. But then here on the next problem, you were just given the amount, where that's all problem 3 was. Right, so you divide these two. That's, you flip this conversion factor, because right now grams is on top, moles is on the bottom. We want moles on top. So it's less than 1 mole, and so the number should be just below Avogadro's number. So that number makes sense. And this is on the test. I would put in another sig fig for the actual mass, but 3 sig figs and 4 sig figs, so your answer should have 3, whatever has less sig figs technically. But I'm not trying to trick anybody with a sig fig or trying to mark anybody wrong. So keep track of them so that I don't have to go back and correct it. But if you get one wrong on the test, and you were off by 1 sig fig or something, I'll give you the point back. Mass percent means you're taking the mass of all the atoms that are there and then whatever you're interested in. So they want us to be interested in sulfur. So with the polyatomic ions like this, the subscript on the outside of the parentheses, you then multiply to each of the elements on the inside. So this is 2 aluminums, 3 sulfurs, and 12 oxygens. All right, then 3 times the mass of sulfur on top divided by the total. Scroll down. Determine the molecular formula of a compound that has a molar mass of 92.6 and an empirical formula of NO2. So what you do here is you take the mass of NO2, right? Oxygen is ballpark 16. There's 2 of them, that's 32. Add nitrogen to that. That's 46. 46 divided by 92, or 92 divided by 46. It's in a 2-to-1 ratio. So that means we need to multiply this equation, NO2 by 2, which gets us to N2O4. So answer A doesn't make any sense because the ratios still aren't the same, right? It's 1 nitrogen to 2 oxygens. This is 2 to 3. That doesn't make any sense. Answer B here would be if we multiplied the empirical formula by 3. So at least it makes sense. Turns out it's not, the right one. C is right. It was a 2-to-1. D would be if the molar mass was the 46. And then E is the incorrect ratio. So A and E make no sense. And then B is where that integer value is 3, N is 2, D is 1. There's something pretty similar on the test to this. I forget if it's a made-up one or just a different, different elements, but same process. 7, write the balanced equation to show the reaction of gaseous ethane with gaseous oxygen to form carbon monoxide and water. So this is where, right, you need to know that O2 is oxygen, right? Oxygen gas is O2, not an oxygen atom. So B and D are wrong because it has the wrong chemical formula for oxygen. All right, then if we look at A and C, it's really just the coefficients, right? So it's really, this is an indirect balancing problem. It looks like they both have 4s for the carbon dioxide, so 2 times 2, okay, that's fine. What other detail are we missing? Carbon monoxide, okay. Okay, here, so this has CO2, right? And it said carbon monoxide, not carbon dioxide. So we eliminate answer B and D because of it needs to have the O2, and then we eliminate answer A because it has CO2 and we want CO. So the correct answer is C. This one we didn't even have to balance, really. I started to look at that and then realized this one's just identifying the correct molecular formulas. Which of the following is a molecular element? A molecular means non-metal. It could be xenon, actually. There won't be one this easy anyway, but sodium's a metal, iron and barium, they're both metals. Molecular means non-metal. I don't really like this question that much, but it could be C or D. Let me just block that. What's the charge on cobalt in C2O3? So this, again, you go back to your periodic table, you find oxygen, it's in group 6, a -2 charge. -2 times 3 is -6. The whole thing's neutral, and so the cobalt has a +6, but there's 2 of them, so 6 divided by 2 means +3. There's one pretty similar to this on the test, right? It's an integer value you'll put in. So this is easy to have in there where either you get it right or you don't. There's no fractions or sig figs or anything. So that's a decent problem. And again, it's got, a little bit of math, but it's pretty short. Same thing here, magnesium nitride. So if you know your polyatomic ions, this isn't one, right? So answer B and E make no sense. We get that, so it's all the same. Page. Now this program, the formatting is a little strange. Nitrogen is in group 5, it's a -3. Magnesium's in group 2, so it's a +2. So their charges are different. Our common denominator is 6, so we need 3 of the magnesium, 2 of the nitrogen. Here's one of these combustion ones. These are important for chem majors and a few bio people, you know, depending on if your OChem instructor finds this important. So I didn't put one of these on the test. This is a little much. I think we could skip that one, since we're like starting to run out of a little bit of time. Let's see. Aluminum metal reacts with aqueous cobalt nitrate to form aqueous aluminum nitrate and cobalt metal. What is the stoichiometry coefficient for aluminum when the chemical equation is balanced using the lowest whole numbers? I didn't put the equation in. So cobalt nitrate, it's cobalt 2. Nitrate is a -1. So you need 2 nitrates for the cobalt. It's saying you're making cobalt metal. Oh, the trick for this is that the aluminum has a +3. So when the aluminum metal reacts, it goes to +3. And you're going to need that much nitrate. So this is again our 2 to 3 ratio. So that's where the value for the cobalt comes from. I'll probably go into this one and have the equation written out. I don't know why it does for all the rest, but it didn't for this one. Let me make this a little bigger too. All right, 13. How many grams of lithium nitride can be formed from 1.75 moles of lithium? Assume excess nitrogen. What type of reaction is this? We didn't cover the types of reactions, so combination is when you have things that add together, right? You can see that combination A plus B goes to C where they're combined. I don't care about the types of reactions, and really a lot of these things no one calls them by these names anymore anyway, so that's a little overkill. And this one, it already balanced it for us, right? Anytime you see a coefficient in front, that means it's already balanced. So if you have 1.75 moles of lithium and it wants to know how much lithium nitride, this is in a 6:2 or 3:1 ratio. So we're going to have you multiply, the 3:1. So you want to get out of moles of lithium. So you're going to divide by 3, and then you'll multiply by the molar mass of the lithium nitride. And it didn't give you the lithium nitride here in this problem like it did up above right here. Usually I give you the lithium nitride on these, you know, maybe on the first test or on one problem, the first test, to make sure you know where it comes from. But after that, it's something you can look up, and I try to minimize looking things up. The next one, according to the following, how many grams of sulfur are formed when 37.6 grams of water are formed? Okay, so what this one is doing is it's comparing these two products, which is a little strange, but whatever, it doesn't really matter. So you can't get straight from grams of one compound to the grams of another. what you have to do is go from the grams of water to moles of water. And then it already gave us coefficients in front. So this is balanced 3:2 ratio. For every 2 moles of water, we'll get 3 moles of sulfur. And then the molar mass of sulfur is 32. Water's 18. So you would divide by 18 and then, multiply by 3, divide by 2, and then multiply by 32. So the number is going to get bigger by those different ratios. So this seems about relevant. Usually I don't put, these numbers are at least different enough, right? You're given 3 sig figs, so your answer should have 3 sig figs, but these ones aren't drastically close. Usually I put in a ridiculously large one, like 2,000 grams, and then something really small like 2 grams or 1 gram. But these ones, they're not close enough to rounding or sig figs or something, right? You're not going to get any of the other answers on your calculator if you do it right and get the right answer of 99.8. Huh. 5 was on the last one. This 1 and 2 were the same ones that were on the end of 4. I think maybe we did that because of an exam where we wanted people, like the exam was on Wednesday or something, and we wanted people that were doing worksheet 5 on Monday or Tuesday to see these 2 problems. Whereas people that had, their 4th hour session was on Friday, they would only see these they wouldn't see these if it was only in worksheet 5. So that's why those 2 were in 4. Anyway, so we don't need to do those 2. Let's take a look at 3. According to the following reaction, what amount of aluminum sulfide remains when 20 grams of aluminum sulfide and 2 grams of water are reacted? So whenever they give you 2 masses or 2 amounts of reactants, that means you have to determine and figure out which one. And this is more reasonable to an online test, right? Even in person, right? Once you've shown where the mass comes from, you don't need to always be with your calculator adding this stuff up. All right, so what you're going to do is take the gram amount, convert it using the molar masses given into the number of moles. And then, we wanted to know what amount will remain. So what amount will remain tells you that the water is the limiting. Okay, so this one is a limiting reagent one, like in reverse a little bit. So what amount will remain, and they're both reactants. So you need to figure out the moles of water, and then that moles you subtract from the total moles of the aluminum sulfide, and then the leftover amount is what's left over. So we know, first thing, let's go and look at the answers, right? A is ridiculous. So if you started with 20 grams and you reacted some with water via this reaction, there's no way to possibly have more, right? B, C, D, and E, they're all possible mathematically. D seems pretty ridiculous. It's really close to 20. So, you don't know until you do the math, how many moles is 2 grams. But the molar masses aren't, ridiculous and far apart in mass. Aluminum sulfide is not some huge compound. Their masses are, an order of magnitude similar to one another. So D seems like it's just way too close to the original mass. Anyway, but to find it, convert grams to moles of each, the amounts given, and then subtract that molar amount, and then convert back to grams, or you could find the gram amount and subtract it from the 20. If you were, if you're crunched for time and you skip this problem, or it's say the last problem on the test, I would eliminate A and D, and then you would be at least have it be down to B, C, and E to take a shot at it, I'd guess. For complete ionic equation for the reaction that occurs, aqueous lithium sulfide and copper nitrate are mixed. Okay, so this is one where you'd have to go and look at those sheets, which I mentioned. I'm not going to have you, give you the sheets and have you look them up. So the one that's on the test is going to describe the whole reaction. This is only describing the reactants, right? And that's why all of these look the same. So what makes them different is that the copper sulfide actually precipitates out, right? And the rest of these don't show that. They show either both precipitating out, which this is extremely rare. And then here the lithium nitrate, which lithium and nitrate are almost soluble in everything. That doesn't make any sense. So there won't be one like this on the test. This is more like a pre-lab question test. Five is a titration. I did put a titration one on the test. So you got 80 mils of an unknown. So whenever it's an unknown, you're looking for the concentration. Requires 126 mils of 0.218 molar KOH. So the trick with this one is that you got 3 protons here and only 1 hydroxide. So from the volume and the molarity, you can find the number of moles of the KOH, and then you need 3 times as much of the KOH as you do the H3PO4. So does the answer make sense? Yeah, so if you look at it, we've got less volume, but we know we need 3 times as much. And since we didn't have, perfectly 3 times much, right? 80 times 3 would be 240 milliliters. And that's not what it is. It's less than that, about half. That means the concentrations, it's going to be higher, well, it's not going to be half this, but it's going to be in the ballpark. So if it was a pure 1-to-1, then the molarity would be the same. If it's 1-to-2, then the volumes aren't quite the same. So this answer seems about correct. 6, according to the following, it tells you it's balanced, but it's balanced because there's already coefficients in there. How many moles of nitric acid are formed from 2.5 moles of NaO2 if there's plenty of water? Plenty of water means that this is your limiting reagent. It only gives you the amount of it anyway, but plenty means excess. This one is sort of a limiting reagent, but it indicates which one. You don't have to figure it out. And then we're in balanced from the NO2. So we're in a 3-to-2 ratio. So we're going to get less. If there was 2.5 moles of it, before you pick up your calculator, you're looking for a number that's less than 2.5. And if you look over here, the answers are all higher than 2.5. So A, B, and C don't make any sense, right? We went from 3 to 2, the number decreased. So we're looking for a number lower than 2.5. The only one lower is D. Which substance is limiting? This one flat out asks it. 12 grams and 18 grams and 24 sodium hydroxide. So this is sort of a tedious one, but that's all it wants, is to know which one. So you need the molar mass of each one. Change the grams into moles for each. And then doesn't matter, and the coefficients are the same for the products 2 and 2. But find out which one would give you the lowest number, thus you would run out of first. So even though we need, and that's probably due to the 4 here, right? Even though we have 24 grams, we have the most mass. The molar mass is going to be the highest for this, and the number of moles needed is the highest. So sort of to the untrained eye, when it says limiting, you might think to just circle the sulfur, but the molar mass of sodium hydroxide is going to be higher, and the amount needed molar wise is higher than the other two. So that's why it ends up being C. You can kind of see that one before you get started. But which of the following solutions will have the highest concentration of fluoride ions? So this is relying on you knowing apart that they break apart into separate ions. So KF, you only get 1 ion per molecular formula. So 0.1 means it's 0.1. SF2, 0.1 molar means 0.2 molar of the fluoride ions. Then even though this one has the 2, it's 0.05. So 0.05 times 2 would be 0.1. That'd be the same as A. It's C that you would get 0.3 molar fluoride ions in solution. 9, here's another. What are we doing here? Is it diluting? How many milliliters of solution contains 0.13 moles? Oh, this is just a molarity one. They gave you the molarity. Molarity is moles over liters. So it's just like density, where you've got M equals, capital M equals moles divided by liters. They gave you the 0.184, that equals 0.113 divided by X. 9, 10. Calculate the number of grams of solute in all right, another calculation one. So there's one on the test, maybe 2, like 9 and 10 grams of solute, 500 mils of 0.169. So this is just taking the one above one step further, sort of, right? Capital M is moles per liter. They're saying you have 0.5 liters. So using the volume in liters, moving that decimal point over, that gets you to the moles, and then the molar mass off the periodic table of KOH. There's 1 or 2 dilution ones on there. Oh, we're out of time. Okay. So I'm pretty sure worksheet 6 doesn't have more of the stuff we're doing, but I'll double check. But we'll pick up here and we'll walk through these last couple ones, and then we'll do the study guide. I'll also send out an email. So if you want, we can go back and cover different problems from whatever, the PowerPoints or any ones that you guys have, or any topic that you're a little unsure of or something. And the study guide is the same as this, but I haven't used these in a long time. The study guide has it where the math is actually worked out and not just the answers shown, which is obviously, I agree that it's better, but we wouldn't have been able to get through all 5. I mean, we almost finished it, but all 5 in an hour if the calculations were there. So questions, comments, thoughts. I hit the unmute, so if you want to actually talk instead of chat box, you can.
On the sig fig portion of the exam, do you want it to be based off like the one with the least number of sig figs or the most?
Well, what we'll be doing, almost every problem in here that we're doing is multiplication. So when you multiply, then your answer needs to have the one with the least number. But usually when it's a fill in the blank, usually what I do is the numbers that I give you all have the same number of sig figs. So
Alright.
I'll give you one where each number you're doing the multiplication with or division with has 3 sig figs. So there's no confusion. Your answer should have 3. 3 is the most common. And then some of them I just put in parentheses, like put 3 sig figs so that it's not. I mean, it doesn't matter in a class this size. It's not hard for me to go and check everyone's exam, but I'm used to one semester I had 370 in one class, and like you can't go back and the whole point of having La Lima is it grades it for you. You can't go and grade 370 individual exams. So
Alright. That and I have question on the stoichiometry part
in general or specific, which one?
in general.
Okay. Like you want me to recover it like on Monday or
Uh, preferably yes on Monday or like some part of it today.
yeah, well, I mean, we're kind of out of time today and it's a broad topic. I'm gonna send out an email to the whole class and then like whoever gives me feedback on stuff, I'll make that part of what we'll do in class. So like I'll like, go back over those, hit those topics again. And I think the worksheet or the study guide has where it has the math showing it solved out. I thought these did too. I haven't touched these in a few years. And for some of them, the math is kind of easy to see, but for others where there's 1 or 2 more conversions, it would be nice, right, if the math was there.
Okay.
I would
Another
I would suggest, sorry to cut you off. I would suggest going back and looking over the lecture videos too from last week when we covered stoichiometry. And then like so it's a lot easier to help you if you have like a specific one that you got lost on, than just sort of generically. Or you and I can set up a time and do it, not during the class time, more specific.
Yeah, I'm gonna try to go over the thing first again, see if it finally makes sense for me.
Okay, cool. Yeah, we got a week, so there's time.
Another question, when we're converting molar masses and whatnot, like for example, just eyeballing here, like 1 mole of like aluminum, 6 grams or something. Is there gonna be like preset molar masses like per mole in the question?
Yeah, usually. So which one was that we just did?
I think it was number 4, worksheet 4.
Yeah.
Like it showed some.
So there'll be one where I don't give it to you because like you should have to prove to me that you can go find it, which was like up here above, it's not given. So there'll be one like that on the test so that that shows me how to go and pick it out or whatever. But then usually for the most part, on the exams, it's like this where I give it to you. So, you know, because I like promise you, you could take N2O4, put it into Google and type like molar mass and it'll give you the answer. So if on a test you could just do that, why am I making you Google things to then do the rest of the math to the problem? Right. So I
Okay.
generally give these to you. It's usually in parentheses or it says it like this. And that also makes it nice for the sig fig so that everybody's using the same molar mass, not 92.01 or just 92, that type of thing.
Okay.
Yeah. Good
Yeah,
question.
I thought we had to do some weird thing to find like a special molar mass.
No, no, I mean, and they're all off the periodic table, but different periodic tables are like a bit more, I don't know what the right word is, anal about the masses. By that I mean, like here's 4.026, where some of them it just says 4.0. It depends on how rigorous, like this one has 15.99 there for oxygen. Most periodic tables just say 16.0. So just so and like usually when the number's that small, and I'm not trying to trick people or like make you get the problem wrong by rounding anyway. So it won't be an issue. And especially the ones where I just give you the periodic table, like, hey, you know, or the molar mass where I say like water and everybody use 18.0.
Okay.
Which is exactly what this one did, right? So it's telling you, and when it's a fill in the blank one, that's more important that I tell you specifically what molar mass to use so that there's no deviation from what answer you get. You know, like, so for example, the one below, if you did this one and you worked out and you got 28.11%, that's just a rounding and your answer's A. You know, notice like answer B isn't 28.13 and answer C isn't 28.11, right? You wouldn't solve and get a number close to this on your calculator and mistakenly put in these other multiple choice answers.
Okay. I think it was, I wanted to say it might have been worksheet 2 where I was kind of confused with how you explained with uh one of the questions. I'm double checking it right now.
Okay, I pulled up two, so I'm not sure.
I remember it having like two, it was worksheet 3, the first one. Silver has an atomic mass of 107.
Oh, well, this is like, so when they say uh like isotope 109, it's really the AMU is really 108.905. This is, you know, hypersensitive, like nuclear physicists do this. So this problem's a little too specific for us, but I mean, it's fine. And what this one's just, this one, like, this is too, the answers are too close. I'm not going to do this on a test, right? This is a little
Okay.
much. This is trying to like trick somebody by, you know, you make a small calculation error or like typo while you're putting it in. And I'm not trying to do that. So
Alright. So how did you get close? How would you have approached it? Since it says 108.905 is 48 per, I'm not even sure. I think the question is just messing with me.
no, it's a strange worded question, and like I hadn't looked at these in a while. So the two is, so the one below it is a normally worded one where you're finding the weighted average. You multiply the amount times the percent. This one, right, here's the amount. So you have to subtract from 100 to get the other percentage. You multiply this times that value, that's the half of it. And then here's the answer, right? So it's giving you the same, it's the same math, but it's shown in a different way. So like it's Z is equal to, I don't know, let's do, it's A times B plus C times D. Whoops. Right. And so
Okay.
Z is this value, right? And then your percents are B and D. So A and B are these, is that value, these two values here. And
Okay.
then you have to, the percent of the percent, or C is the value subtracted from 100, and you're solving for D.
Oh, okay. That makes sense now.
But that's not the normal way that it was presented, and you approach the problem like down here. So down here in this one, this is the more typical way it was presented, where here it gave you A through D, you multiply them together, add them together, and you find Z. So it's the same math, it's just you're solving for a different unknown. So the wording of it in one is kind of odd. So don't, like, when I was reading it, I was like, this is strange, you know, worded strangely, and because I hadn't seen it in a long time.
Alright.
Yeah.
And and just to verify for the second one, all you did was 44.8776 times that by 33%. And then
Yeah.
did the same thing for the bottom one, and then you just average those two numbers up.
Then you just add them together. Right. So when you put the percents in there, that makes it the weighted average. Like a normal average is you just divide by 2, which is the equivalent of multiplying by 0.5. So this is just how you do a weighted average. But yes, if you round this off, so 45 times 33 and then 47 times 67 gives you the value that you would see on the periodic table.
Oh, okay. Yeah, I
Yeah.
got that confused with the averaging part.
So weighted averages show that the true value is closer to whichever isotope is larger. And then that's why this one above is kind of strange, because 48%, in the grand scheme of life, like if a bill came and you were out to dinner and your friend was like, no, I'm paying 48%. And you're like, that's really close to 50. We're talking about a dollar. Like, you know what I mean?
Yeah.
Yeah. So,
All right. I think that's all for now. Probably send you an email when I get lost again completely.
all right. No worries. Sounds good.
How we
Oh,
going?
all right.
Oh, what?
Nothing. Everyone else took off. So yeah, let me know. Send me emails and I'll see you Monday.
How we going?
Cool.